Okay. So a 0.25 kilogram ball traveling east at 4.5 meters per second collides with a 0.3 kilogram steel ball traveling west at 5 meters per second. After the collision, the 3 kilogram ball is traveling east with a speed of 0.4 meters per second. What is the final velocity of the 0.25 kilogram ball? All right, so I know that just seemed like there was like a whole bunch of stuff there. We gotta start to make sense of this, right? It helps with a picture, and we just get our numbers put in like one by one there, right? So let's do a picture of before. Try to write a little small too here. So let's go before. So we had a 0.25 kilogram ball traveling east, right? So let's try that one. So we had a ball here traveling east, and it had a mass of 0.25 kilograms. It had a velocity of positive 4.50 meters per second. Right, so, and then the other one, so we had a different ball, and it's going the other way. And it was, oh, yeah, sorry, and I'll say mass 2, I should label those 1 and 2. So I'll go back to that. So mass 2 is going to be 0.30 kilograms, and a V2 is going to be negative 5 meters per second. Here, this should be an M1 and V1. Okay, so there's our picture before. Now let's get our picture after. So after, we've got M1, and, well, M1's still the same, so you can write that in there too, so 0.25 kilograms. And the V, we don't know, right? That's the thing we don't know for that one. But then we do know that M2, which is still 0.3 kilograms, it leaves with a V2 of positive 0.4 meters per second. Okay, and what we should have here is a little tick there up in the top to remind us that that's after, right? That's the prime. So we'll do that on this one too, so that's like V1 prime that we're looking for. Okay, so that's our picture, right? We've got it all kind of like set up. Now what do we do? What's going to be our process here now? We'll say, right, sum of momentums before is equal to the sum of momentums after. So the mathy way of doing that is sum of the momentums, so sum of momentums before is equal to the sum of the momentums after. So a little tick. Technically, you'd have little arrows over the top of those, right? So they were vectors. All right, so now we just kind of fill it in. So momentum for each one of these is going to be M1V, like M1, V1. So let's just do that. So we'll have M1, V1, and there'd be a little vector over V1, plus M2, V2 is equal to M1, V1 prime plus M2, V2 prime. There. That's us setting up the equation, right? Just momentums before and momentums after. All right, so now we're after this guy, right? In this equation. So what I'm going to do here, this isn't so bad to do like the whole thing algebraically here too, right? I can get rid of this term, right? The whole thing, really by just subtracting M2, V2 prime from both sides, right? Is really what's going to happen there. Or the other thing that I do in my mind is I'm like, okay, it's positive on this side. It would be negative on that side, right? So I can just do that part really quick. So let's write that out again. So now we're going to have M1, V1 plus M2, V2, and then minus M2, V2 prime. And then, are you guys okay that I just had M and V1 up here? To get rid of that M1, I would just divide both sides by M1, right? So it just go to the bottom. So that's just all over M1, and that's equal to V1 prime. Okay, and then after that, we're just throwing stuff in, right? We're just throwing stuff into our equation, making sure that we get our directions right, right? Like what if it's negative, it goes in as negative, positive goes in as positive. So can you guys do that for me? Let's see if we got room. So M1, so we got, I'm gonna run out of time here. Are you guys okay for this, if I just kind of jump the answer, just so we have more time to do the other questions? Okay, and so give it a try. If you get the wrong answers, then it's something to do with a negative or positive there, right? So in the end, here, it ends up being 1.98 meters per second west. Yeah, so that would have come out as a negative, right? So then you would have said that, okay, negative is actually west when we're looking at that. Okay, freight train is being assembled in a switching yard. Boxcar 1 has a mass of that and moves with a velocity of 0.8 meters per second. Boxcar 2 with a mass of that and a velocity of 1.2 meters per second overtakes Boxcar 1 and couples with it. So neglecting friction, find the common velocity of the two cars after they couple. So in this situation, right, before it was that they hit and then they travel off with different momentums, right, different velocities. This one, they hit and stick together. So now they're traveling as one, right? So we handle this just a little bit different. So the way we're going to do this, so again, we can do the before and after. You know what, again, for the sake of time, I'm going to stick with pictures, but the pictures are handy a lot of times. But let's just go the sum of momentums before, so an arrow, is equal to the sum of the momentums after. Okay, so momentums before, right? We had Boxcar 1, right? We had that mass, and they gave us a velocity. And we had Boxcar 2 with that mass and that velocity, right? So that was both before, right? So I can just put those in, right? So I'll say it's M1 V1 plus M2 V2. This is boxcar, the momentum of Boxcar 1, Boxcar 2. Okay, and then after, what do you guys think we're going to do here now? Like to get, like they're together now, right? Well, they're going to have one velocity, right? So they share that.
And they're going to have
a single mass, which will just be those two masses added together, right? It's going to be those two masses added
So when
together.
they hit, do they slow down or do they speed up?
They would end up, because they would add, right? So they would end up speeding up. Well, it depends. The one would slow down, the other one would speed up. Yeah. If you're thinking about them individually, yeah. Okay, so the way this is going to look then is we're going to say M1 plus M2 times, and then I'm just going to say V prime, because this is like my 1 and 2. You could say 1 and 2 as a subscript if you like, or just, you know, V just to remind yourself there. And then that's really it. So it says common velocity, right? So if I want to get V on its own here now, yeah, I can divide by this whole thing, right? Everything in brackets there. You can just divide both sides by that. So in the end, that just really comes down to the bottom, right? Yeah, okay. So I'm going to write this out as M1 V1 plus M2 V2 divided by M1 plus M2. And that's equal to V prime. You guys want me to go put the numbers in?
No.
Okay. I think you just need to try to get the right answers in. If you get the wrong answer, then you look at what you did there. But that really would be it. You can throw the numbers in and kind of go from there, making sure that your velocities, right? These should have really been vectors there on that to remind you that those could be negative or positive. All right, next one. All right, starting from rest, two skaters push off against each other on a smooth, level ice. One is a woman with a mass of 54 kilograms, and the other is a man with a mass of 88 kilograms. After pushing off, the woman moves away with a velocity of positive 2.5 meters per second. Find the recoil velocity of the man. So first off, recoil means like you guys don't know like guns, right? Like recoil on the gun means like pushing back on you. This is actually, we didn't talk much about it, but like in the notes there, but this is like an explosion question. Because this thing, or these two people, what's their momentum before this happens? Zero. That's the same type of thing as like an explosion, like a bomb. You handle it the same way, where it would have zero momentum to begin with. It's just a bomb sitting there. And then afterward, it's going to explode. One piece goes this way, one piece goes that way. But they should add up to zero again.
So maybe both of the velocities have to be zero.
To begin with, well, so what? Let's go through here. So it'd be, you can do the same thing. We'd say sum of the momentums before is equal to the sum of the momentums after. And you could write it out, like, don't write this, but like you could write it like this, right? Mass times mass 1 times velocity 1 plus mass 2 times velocity 2, right? But then the velocity of both of those was zero. So all of this stuff on the before side is just really zero, right? And that's how we handle these explosion questions. So if you know that, you don't need to write that all out and put zero in for velocities. We can just say zero, right? Momentums before were zero.
So 0 is equal to
Yeah, and then
M1 and V1 plus M.
yeah, you can write them after if you want, or there's only, you won't get confused here now. There's only these ones. So M1 V1 plus M2 V2. And so we want V2 on its own, right? So I can bring this over here. So we're going to end up with negative M1 V1 is equal to M2 V2. Yeah, and you would, but just notice this for a second too. I just want you guys can't see this, right? The way we have it set up right now, that makes sense, doesn't it? That the momentum of the one person would be the same as the momentum as the other person, just with the negative, like in the opposite direction, right? So this, both ways, like this way and this way of looking at it, should make sense, right? So that's what's happening. Okay, so then in the end, yeah, divide by M2, so we're going to get negative M1 V1 over M2. So this one didn't actually turn out to be that much math involved, right? So put it all in. Here, I got time to put this one. So we'll go negative 54 kilograms. And then V1 was positive 2.5 meters per second. And then divided by 88 kilograms. And that was all equal to V2. So in the end, that ends up being negative 1.5 meters per second. Good? Not too bad, eh? Good. Okay, one that I just want to kind of go back on. I won't do it, but I just want to tell you guys how you would do one like this. So this would be kind of like a tougher little question. So example 9, I skipped over before. Says in the diagram below, ball A, so this one, has mass 5 kilograms, it's traveling to the left at 12 meters per second, collides with a stationary ball B. After the collision, ball A is moving with 5 meters per second to the left. How high up the incline will ball B rise before coming to rest? So
we have to find V2 of V.
Right. Here's our issue, right, is that I don't know what the velocity of ball B is after, right? I don't know the prime, like where it's going after, right? So we could solve that the same way we were just solving those questions, right? We figure out the final velocity of B2 there. But then how can I use that to figure out how far up the ramp goes? It'd be hard with kinematics. Yeah, we'd have to, like, we do know the angle and that kind of stuff too, but yeah. What else do we know here? We know traveling 12 minutes away, how far up the ramp. Oh, wait, yeah. So we do know that this is 20 degrees.
So wouldn't we find?
Any ideas? I'm kind of looking at like people who just like physics 20 because if you haven't taken physics 20, well, you might forget those. Or I'm sure you will.
Well, if you find how the velocity of it in the X,
Yeah.
you can use whatever to find it on the. But that doesn't really make any sense because when you have to take gravity into account.
We can do it easier than that. This is actually why our energetics unit was kind of invented originally, right?
Oh, we have to find the height.
Yeah, we just gotta find this. Like, well, we can figure out the height, right? And then from that, we can figure out how far up the ramp, right? Because if we know this, right, and then you know the angle, we can use trigonometry to figure out your distance up the ramp. So again, though, how do I find that height? Maybe it would look easier if I wrote it as an H. What formula did we use H in last year? MGH, right? So the energy that we had right here, right? EK, it was all EK right here, this ball. When it's up here on the top of this ramp, it's all EP. So I should be able to say EK is equal to EP and solve for H.
So we have to find the velocity first.
Right. So that's the thing. We had to find the velocity from step one.
So it's a
And then it's a two-part question. You'd use what we just did to find the velocity of ball B. And then once you do that velocity of ball B, then we know the kinetic energy really now, right? And then EK is equal to EP, so you set those equal to each other. Solve for H. Oh, here, I'll write it down. So it's EK is equal to EP. So we'd say 1/2 mb squared is equal to mgh. So mass is actually canceled. We had them both though. We could have used it,
Yeah.
but they cancel anyway. We know velocity, and we're just solving for h. Yeah, move g down. You get your h, and then it says how far up the ramp though. So now we've got one side. We have the angle. We can just use SOHCAHTOA to solve for that.
But the equation for the other one would look, for the first part would look a little bit different, right? It would just be, because B isn't moving before.
Right. So that's why it only had one term to begin with.
Right.
Because the other one was 0, right? Like ball B would have been at a momentum of 0 right there, so we didn't need to write it.
Mm-hmm.
Yeah. So it's all for B, and then, like I said, you can solve for the height, and then once you have the height, you can use SOHCAHTOA to solve for how far up the ramp you go.
Right.
So this is an example of how the questions can be a little bit tougher, right? They take, it's more of an application question. It's not just plugging it in, and you guys will get questions like this, right? So,
Nice.
yeah. Okay.